Okay, so I'm going to start again from the beginning and work through this example. The demand function, P of X, is the price per unit that a company can charge if it sells X units. The revenue function, R of X, is X times P of X. That is, we take the number sold and we multiply it by the price. Our marginal revenue is the derivative of our revenue function. For maximum profits, marginal revenue will equal marginal cost. And we talked about this a little bit yesterday. We said if I wanted to calculate my profit is equal to my revenue minus my cost. If the goal here is to maximize profit, then I'm going to take the derivative and find the critical numbers. Set it equal to 0 or undefined. If I've got profit equals revenue minus cost, then P prime equals R prime minus C prime. Then my P prime, marginal profit, is 0 if R minus C prime is 0. That is, if R prime is equal to C prime. Okay, so here's how we're going to apply this. So maximum profit occurs when this is true. So Howard's Hamburgers has a yearly demand function, that is the price, is determined by this equation. P is equal to 800,000 minus X over 200,000. Okay, so that's how the price is set. Here's the cost function. C of X is equal to 125,000 plus 0.42X. So it sounds like his costs are pretty basic to calculate, some kind of a fixed cost, and then a per unit of hamburger produced. It's not costing him very much to make hamburgers, but he sure had to shell out a whole lot of money to get started. 125,000. What level of sales will maximize his profit? Okay, so we're trying to make this happen. Let's start off by writing out a revenue function. Our revenue function is equal to X times P at X. And P at X has been given. This would be X times 800,000 minus X all over 200,000. Okay, let's simplify this. This is going to give me 800,000 over 200,000 minus X over 200,000 multiplied by X. Can we see this algebra without a couple of steps involved? Okay, so have a look at that and make sure that it makes sense to you. Okay, the 200,000 divided both of the terms, made that a 4, minus X over 200,000, and distributed the X through. 2 steps in one. Okay, then we've got our revenue function and we've been given a cost function. So I guess I need to know what is R prime at X. So let's take the derivative of this function. That's going to give me 4 minus 2X over 200,000. Simplifying, I get 4 minus X over 100,000. So this is R prime. What's C prime? Here's my cost function. C prime at X, taking the derivative of a constant, I get 0. Derivative of 0.42X is just 0.42. Okay, so if R prime is equal to C prime, then 4 minus X over 100,000 will equal 0.42. I'm going to subtract 42 cents from both sides. I've got 3.58. I'm going to add X over 100,000 to both sides. and solve for x, multiply both sides by 100,000, I get 358,000 is equal to x. Okay, what did that x represent? Well, here's our demand function. We probably should have set up a little key before we started, where x is equal to number of burgers sold. That's a lot of hamburgers. You had a question? Okay. Okay, so question, what level of sales will maximize profits? He will maximize profit when he sells 358,000 hamburgers a year. Okay, so to maximize profit, he needs to sell Okay, I just have another question for you. What is Howard's profit? At this sales level? Well, then his profit is going to be his revenue minus his cost. That his profit at 358,000 is going to equal the revenue at 358,000 minus the cost at 358,000. So plug that into all of those functions and tell me what you get.